So now we're going to be doing ionic bonding. And we're going to start simple and then it's going to get more complicated. Okay. So the types of elements that create ionic bonds are going to be metals and nonmetals.
I need more tea.
Gotcha. I'm doing a video. Okay. And the electronegative difference between the elements in ionic bond is going to be over 0.8. Wait on, that's not right. It's 1.8 to 4.0. Y'all, I got distracted. It's Miss Haverday's fault. That's what we're gonna say. But that rule is really bad, so we're not even gonna focus on that much. So how does ionic bonding work? Right, we should have already reviewed this a couple times, but your cation loses electrons to anions. Okay, so again, cations, you're going to draw a cat with plus i's, right? And on posters that have cats, right, way back in the 90s and 80s when we all grew up, right, we had pictures of lost cats. It says lost electrons, right? That's how you're going to remember your cation, right? Versus your anion, we're going to draw an ant. We're going to make him a mean ant too, because he's negative. Okay, so we're going to give him antennas that are negative. So we're going to pretend like this is a happy cat. Happy cat, because it's positive. I'm going to give him a paw too, because he's positive. Okay, and then I have an anion, 4, 5, 6, that is negative, okay, because it gains electrons. Okay, so to teach you how to do ionic bonding, we're going to start with magnesium and oxygen. Magnesium is in group 2. So I know that magnesium has has 2 electrons. 1, 2. Oxygen is in group 16, so I'm going to do 6 valence electrons. 1, 2, 3, 4, 5, 6. Okay? So these lone pairs can be left alone. They're happy together. We don't mess with them, right? But these are our single ladies, right? We're going to match them up. So this electron is going to come here, and this electron is going to be happy here. Magnesium now just has a positive charge because it gave away 2 electrons. And then oxygen has 1, 2, 3, 4, 5, 6, 7, 8, right? And now it's going to have a negative 2 charge. Okay? Your cation always comes first. Positivity always first. If your charges cancel out, right, I only need one of these each. So you just write the symbols. So the name for this guy is going to be Mg, or the chemical formula is going to be MgO. I don't have to do anything else because my 2 minus 2 is 0. Okay? It's all satisfied. But most of the time it doesn't work like that. So now we're going to do magnesium and chlorine. Okay? So magnesium, again, I have 2 valence electron. Chlorine is in group 17, so it's going to have 7. 1, 2, 3, 4, 5, 6, 7. All right, so great. I can give this electron here. Circle these. But this guy is super unhappy, right? Because it's by itself. So we need to find another electron for it to join. So in this case, I'm going to put another chlorine on the other side. 1, 2, 3, 4, 5, 6, 7. Okay, and I'm going to bring this electron over here. Now magnesium is happy. And it has a +2 charge. And then my chlorines are each happy, right? Because they each have -1 charge. Okay. So my chemical symbol for this, my chemical formula for this is MgCl2. Because I have one Mg and I have 2 Cl's. Okay? So if the oxidation numbers are written, write the oxidation as a superscript. And please do not ask if you have to do this and show your work. The answer is yes. Because way too often we have students who mess up their ionic naming and covalent naming. Okay, if you follow directions all the way through, you're going to be fine. Okay, so chlorine is going to be -1. You're going to crisscross those superscripts so that they become subscripts and get rid of the negative sign. Positive and negative sign. So, it's going to be Mg1, which I don't have to write, Cl2. Okay. Let me see. Okay. So, let's do a little bit of practice. Let's do it here. Okay. So for sodium phosphide, I'm going to have Na. Phosphorus is in group 15. Right? So sodium is going to be a +1. Phosphorus is going to be a -3. So all I do is I cross those oxidation numbers, and it's going to be Na3P. Okay? But let me see if I can come up with a... Let's do calcium oxide. Okay? Calcium has an oxidation number of +2. Oxygen has -2. Right? In this case, I don't cancel out because 2 minus 2 is 0. So it's just going to be CaO. And so prefixes are for covalent only. So write that down. Prefix for covalent only. Okay? So if it's ionic, you just write the name. Okay? So it's going to be potassium, not dipotassium, potassium. And again, I don't end my compounds with sulfur. Potassium sulfur is not a thing. You write potassium sulfide. Okay, so that is level 1 on that. Let me come back here. All right, so transition metals. Okay, for transition metals, do not follow the group rule and have multiple oxidation numbers. What do the Roman numerals indicate? They indicate oxidation number. write the oxidation number just like all other formulas, right? So copper is going to be copper, Cu, plus 2 on the top, okay? Way too often people put their 2's here. This is why it's so important to do your oxidation numbers right the first time, okay? So copper 2, chloride, which chlorine always has a -1. Okay, now that I know my oxidation numbers, I know what to do because I've been following the rules. I'm just going to cross these down. Cross, cross. It's going to be Cu, Cl, 2. Okay, so when let's do a practice here. Okay, chromium is going to be Cr. That 4 goes on top, not on the bottom. Phosphide, which phosphorus is in group 15, so it's going to be a -3. I'm going to cross down, and it's going to be Cr, 3, P, 4. Okay. If you need to pause so that you know what's going on, please make sure you do so. Okay. When we're going to naming, we're going to do the opposite. Here are a lot of rules, so try to keep them in check, right? Try to put them in order. In stock naming, cross the subscripts up and get oxidation number. Do not forget to write oxidation number in Roman numerals. Okay, I did not give you an example on my paper for some reason, which is fine. So we're going to do 2 examples here. All right. So for Cu, Cl2, you're going to cross up. It's going to be Cu plus 2, Cl -1. If you get the wrong oxidation number, then you need to multiply, you need to multiply so that you get the right number. Okay, so I'll give you an example in a minute. Okay, so this is going to be copper 2 chloride, right? Because our binaries always end with IDE. One thing that I have not mentioned is that the reason that we're doing this is because transition metals all have multiple oxidation numbers. So you have to know which one it is, right? Different oxidation numbers and charges have different qualities, okay? So that is why we're doing that. Okay, let's do one more here. So I'm going to do this one because this one is going to come out wrong. So PbO2, I'm going to cross up and cross up. So that says Pb plus 2, O minus 1. But we all know that oxygen is not a -1. We know it's a -2, so we need to multiply both by 2 to keep it balanced. Okay, so it's going to be Pb 4 O -2. Okay, so then OPB, I'm pretty sure that's lead, right? Yeah, it's lead. Lead 4 oxide. All right, and then I have to stop there because, like the last time I did a video, it's time for class, and so I'm going to be late. So we will do the rest later.